Okay, welcome you all for this new session on Rayleigh's method. Okay, why Rayleigh's methods are used to find the natural frequency of the system. This is the equations to find the natural frequency of the system by using the Rayleigh's method. Fn means frequency in hertz, and omega n, it is the frequency in radian per second. Okay, 1 by 2 pi square root of g summation of mi yi, where m is the masses for the 3 degree of freedom of system, m1, m2, m3, where y is the deflection at point 1, point 2, point 3. For 3 degree of freedom system, it is y1, y2, y3. So it is deflection at point 1, point 2 and point 3. Okay, we are using this equation to find the natural frequency of the systems. How to find y1? To find the y1, we are using this equation. It is for 2 degree of freedom system, m1 g a11 plus m2 g a12. Similarly, to find the deflection at the point 2 or at the position of the mass 2, that is equal to m1 g a21 plus m2 g a22. Okay, for 3 degree systems, you can add one more term here. y1 is equal to m1 g a11 plus m2 g a12 plus m3 g a13. Similarly, y2 m1 g a21 plus m2 g a22 plus m3 g a23. Similarly, y3 is there. Okay, where y1, y2 are the deflections at the position of the mass 1 and y2 is the deflection of the mass 2. Okay, let us solve some numerical problems where by using Rayleigh's method. Okay, here a11, a12 are the influence coefficients. Okay, if you don't see my video on the influence coefficients, you can just follow that video on the influence coefficients. Okay, let us solve this problem. It is a cantilever beam. First, you find what are the influence coefficients. Okay, there are two masses, mass 1 and mass 2. So it is a 2 degree of freedom system. For 2 degree of freedom system, there are 4 influence coefficients. You find influence coefficient first. If you don't know influence coefficient, you just refer my previous video. Okay, we are finding the Rayleigh's method. I already told, to find the Rayleigh's method we need y1 and y2. For 2 degree of freedom system, y1 and a2. First you find what is a11, a12, a21, a22. These are the influence coefficients. First you find influence coefficients. Okay, I already told how to find the influence coefficients in my previous videos. You refer it. Now a11, a22, a12, it is calculated here. Okay, then you substitute the value of a11, a12. What are masses here? Mass 1 it is 100 kg, mass 2 is 50 kg. Substitute the value of mass. G is 9.81, a1 it is calculated here, so you will get y1. Similarly, y2. Then substituting, okay, for 2 degree of system it is g into m1 y1 plus m2 y2. Okay, divided by, for the 2 degree of freedom system, m1 y1 square plus m2 y2 square. y1 y2 you calculate by these equations, where m1 is 100 kg, m2 is 50 kg, g is 9.81. You find a11, it is 2.4796 into 10 raised to minus 8. a12 it is 4.95 into 10 raised to minus 8. Similarly, y2, you substitute the value of a21, a22 and mass m1 and m2. Okay, then substituting all these values in this equation, it is natural frequency of the system in radian per second. Okay, this is how natural frequency is calculated by the Rayleigh's method. We will see one more problem. Okay, it is simply supported beam where we have two masses. Again, you need to find y1 and y2. For the simply supported beam, I already posted a video to find the influence coefficient, how the influence coefficients are calculated. Okay, you find y1 and y2, substitute the value of a1, a11, a12, a21, a22 to get y1 and y2. Then you substitute all the values in this equation, you will get a natural frequency of the system. Okay, this is the method to find the influence coefficients. You refer my previous videos, okay, to find the influence coefficients. Okay, this is also one more problem. It is on simply supported beam with 3 masses. So it is 3 degree of freedom system. For 3 degree of freedom system there are 9 influence coefficients. Okay, it is already posted in the previous session, how to find the influence coefficients for the simply supported beam with 3 masses. Okay, so for the 3 masses, what is the deflection of mass 1, mass 2, mass 3? It is y1, y2, y3. We are using these equations. You substitute the value of m1, m2, m3 in all the equations, and also a11, a12, a13, all the influence coefficients, and find y1, y2, y3. Okay, mass 1 it is 5 kg, mass 2 10 kg, mass 3 5 kg. Substituting all these values, you will get y1, y2, y3. Then using these equations, omega n is equal to square root of g into summation. So we have 3 masses here, g into m1 y1 plus m2 y2 plus m3 y3 divided by summation of mi yi square is equal to m1 y1 square plus m2 y2 square plus m3 y3 square. Okay, you find y1, y2, y3 first, then substitute these values here. Okay, you will get a natural frequency of the system. Okay, we'll consider one more problem here. Okay, it is also 3 degree of freedom system. Okay, I already posted for this mass spring system how to find the influence coefficients. Okay, you refer that video and find the influence coefficients, and then using this equation find the natural frequency of the system. Okay, this is also simply supported beam. It is repeating here with the different masses. Here it is 15 kg, 25 kg, 35 kg. You first find what are y1, y2 and y3. Okay, to find y1 again we are using the same equations, that is m1g a11, m2g a12, m3g a23. Okay, where m1, m2, m3 are given in the figure, and you find what are the influence coefficients for the given problem. Substituting all these values in this equations, you will get a natural frequency of the system. Okay, square root of g into, for 3 degree of freedom system it is m1 y1 plus m2 y2 plus m3 y3. What is y1? It is y1. Okay, where m1 is mass 1, a11 is the influence coefficient. Similarly, you put all these values and find y1, similarly y2, y3, and substitute all these values in this equation. You will get the natural frequency of the system. Okay, thank you very much.